In this video, we will discuss free groups. We have already discussed free product of groups. Now, in this case, if we take G to be any group, and let us take A alpha to be any family of elements of G, then we will say that A alpha generate G if every element of G can be written as a product of powers of elements A alphas. And if this family A alpha is a finite family of elements of G, then we say G is finitely generated. And now let us take that each A alpha that generates an infinite cyclic group G alpha. That means if we take G alpha to be the infinite cyclic group generated by A alpha, and if G is free product of the groups G alphas, then we say G is a free group, and the family A alpha this is called a system of free generators for the group G. Now in this case, every element X of G can be written as a product of product of powers of A alphas. That means for every element of G, there is a unique reduced word in the elements of the group G alpha, which represents X. So we can say that if X is not equal to 1, then X can be written uniquely as A alpha 1 raised to N1 up to A alpha k raised to Nk, where alpha I is not equal to alpha I plus 1, because we are assuming this is reduced word. So no two consecutive element belong to same group. And Ni is not equal to 0 for each I, because if Ni is equal to 0, then that element becomes a density element. Now we have extension property for this free groups, and this is similar to extension property of free products. And suppose G is a group, and A alpha is a family of elements of G, and G is a free group with the system of free generators A alpha. So G has this extension property given by star. Given any group H and any family Y alpha of elements of H, there exists a homomorphism H from G to H such that H of A alpha, this is equal to Y alpha for each alpha. And this homomorphism H is unique. Now conversely, if this extension condition star holds, then G will be a free group with system of free generators A alpha. So the proof is similar to the previous extension conditions. If G is free group with these generators A alphas, then obviously the groups G alpha, they will be generated by A alpha and they will be infinite cyclic. So there will be a homomorphism H alpha from G alpha to H, which satisfies H alpha at A alpha is equal to Y alpha by the extension condition of external free products. And similarly, we can prove the converse part. To prove the converse for any fixed index beta, we assume that small h from G to Z, where Z is additive abelian group, that is defined by h of a beta is equal to 1 and h of a alpha is equal to 0 for all alpha not equals to beta. And then the group G beta, that will be infinite cyclic group, and then we apply again the extension condition to get the inverse converse part. So this completes the proof of this result. Now in the next result, we can say that if G is, in the next result, we can say that if G is this G1 star G2 and G1, this is free group with the system of generators A alpha, where alpha belongs to J, and G2 is a free group with system of generators A beta, where beta belongs to K. And if J and K are disjoint, then G will be a free group with A alpha, where alpha belongs to J union K. And this is the system of free generators for the group G. So this completes the proof of this result.